All right. So now that we have a nice little tile map struct that's going to store our data for us, and we have it in our global data container, do we want to write it like this, or do we want to write it more like this? You know, making it kind of I think if we write it like this, it can be, I don't know, I feel like it can be easier to look at sometimes because you don't see the word global data all over the place. And also, you're kind of like forced to move everything in one nice little package. Whereas if we have a whole bunch of variables and we're like global data dot whatever, and then global data dot whatever, blah, blah, blah. If we do it like this, right, equals whatever, when we're moving it around, right, we have to have the discipline to kind of move it like this. And there's the potential to, you know, end up with part of our population of that data in one place and then in another place, and that that kind of defeats the whole purpose of kind of like centralizing this global data into like one container. So writing it like this can be helpful, and then also to make sure we don't accidentally add anything to this global data after we've populated it, we can just do like object.seal. I'm going to just be doing object.seal all over the place if you haven't realized that already. Object.seal, global data. And let's check out the top screen and make sure I didn't screw anything up. Okay, looks good. All right. So now that we have this, we want to fill this tile map data with some type of default pattern. I want to go with that donut pattern we used earlier. So let's find that donut pattern kind of code that we created and kind of abstract it so that it doesn't just work with the canvas. Because right now that code works with the canvas, but we want to get it to where we can use a uint8 array. So let's see, fill viewport with test pattern, and it was number 3 that we kind of had the donut in, the big donut. But then again, well, it doesn't really matter, right? These are all going to the same function. Let's go find it. All right, so here's our distance formula, and then figuring out if we're inside or outside of that tube. And then I believe we had coloring based on which quadrant we were in. So this CX, CY. So let's see. Yeah, so quadrant coloring right here. And if we are inside the donut at all in the first place. And then we see canvas adapter dot PutPics. So we want to change this to where we can use a uint8 array. So we could totally refactor this code to where the uint array is taken in here. But then we got to refactor a lot of different spots. So I think what would be easier is if we create like a fill uint8 array with test pattern function, and then this function will call that function, right? So the way we're going to do that is we're just going to go over here, and I'm going to just say, what do we want to do here? Let's copy all this code, and we'll say fill uint8 array with test pattern, right? And then instead of this being a canvas adapter, it's going to be a u8a array like that. No, well, let's use the same variable. It was going back up here. It was map, right? This is the actual data. So for consistency, so we can see those connections, we should probably name it the same thing. So we'll put that here, and then we can make a note that it's like tile map.map u8 array, like that. So we know where we're getting this from. And from there, we have this PutPics and GetPics, but we're gonna kind of have to like inline some logic here. And we're no longer gonna call apply, right? Because it's just not a thing anymore. So let's put a breakpoint here, and then let's go look at the PutPics. And we can probably like just grab some code for that putter. Okay, so PutPics. And so this is the basic code, right? So this is our number of components per pixel. And let's see, the input RGB. And these are our X's and Y's. So we're going to take this and we're kind of like going to inline it, right? So going back to this PutPics, we can comment that out, and then we can go like this. And then just make a little section here. Okay, so this right here is this, right? I'm pretty sure we can just access the raw uint array directly like that, so I think we're good there. And then this is our RGB, right? The input RGB. And we can make a note here in RGB. Slash RGB input RGB. All right, and then we'll take this and we'll put this. Oh, sorry, we'll put this down here. So we don't really need to have this extra step of indirection anymore. But you know what? I'm not gonna fret about it. Do we have any variable collisions? Okay, dex. Alright, so this is... I'm going to make a little comment here that inlined pixel setting code below. Or maybe make a little room there. Or do we want... Or do we want it like oh no, maybe something like that. And then eventually maybe we'll get rid of this comment here, because this is kind of like what it's doing. But we've kind of like inlined the source code for this function into here. I don't know. I think that's good enough, and then we'll have the number of components. And if we're taking the raw uint array, then the width and whatnot, we're gonna need to get a hold of that. So we gotta underscore w, right, which is for width. That was, we gotta refactor that as well. BoundingRect. Right, that's the region we want to fill. Alright, so we'll take... that's a lot of stuff. Do we really want to pack it like that? Test pattern. Huh. So right now I'm thinking, do we really want to have all these? Do we really want to have a whole bunch of parameters provided to this, or do we just want to supply the outer container and then a bounding rectangle? And then instead of calling it fill uint A array with test pattern, right, we would call it like fill tile map with test pattern. Let's go for the cleaner solution, because a lot of times when you're like, oh, maybe I'll need it for this, so we should make it super generic. Now you've just made your code. The more generic you make your code, the kind of harder it is to understand, right? And you really shouldn't over-generify your code until you absolutely need that generic aspect, right? So like right here, kind of like how we're ripping out some of the source code for this and kind of like making it more generic because now we need it for a more generic purpose, that's fine. But we didn't generify it until we needed it, right? And so getting this generic, where we're like filling a uint A array, and that's the name of the function, I don't think we should get that generic. I think we should be more specific and say that we're going to fill a tile map with a test pattern, and then we don't have to do this. We don't have to provide you know, the uint A array and then the width of the array and then the height of the array and then also the number of components, right? So all this, like, this is a bit much, and really we could just do this, right? And then this has the width and the height and the number of components and then the raw data that we actually want to affect. And then we will just call this something different now. We'll call it fill tile map with test pattern, right? So find, oop, wait, hold on. I must have spelled that wrong. Fill tile map with test pattern. Okay, so we got it. We're gonna name it like that. And then we're gonna go up to where we construct the data. So create uint A tile map data. And okay, so the data is created here. And then we'll just do the function call here on that tile map. And why do we have that other viewport? Oh, because we have the option to supply like a viewport so we can paste. But do we really need that viewport? No, we don't. Okay, so we're gonna. Okay. So then we really don't need this BoundingRect, right? Because we're not even gonna, right? The bounds are going to be the entire tile map. We're not gonna try to like fill a sub-region of that test data. That would just be, that's just too much. We don't really need to do that. So we're gonna chop this up a bit and BoundingRect. So what we're gonna do is we're gonna actually take this variable, the bounding rectangle, and we're just gonna put it down here and like fill it with this data. That would be the quickest way to refactor this and get it working. So we'll do it that way. So var BoundingRect, and we have the x0 is 0, the y0 is 0, right? Because we're going to fill the entire tile map. And then the x1, and this is inclusive, right? My rectangles, when I do rectangles, I do them point to point. The top left corner inclusive, and then the bottom right corner inclusive. So since we're using inclusive points, we're going to need the width of that tile map. So the tile map dot map width and -1. For example, if we have a tile map that is one pixel by 1 pixel, then the last x coordinate is 0, right? It's 0 to 0, right? So a 1 pixel tile map would be from 0 to 0, 0 comma 0 to 0 comma 0. So when I'm trying to think of edge cases, it's kind of easier to figure out what the answer is for those edge cases by figuring out the smallest smallest example, right? So trying to figure out how the math is going to work, it's going to be hard if I'm trying to think about okay, it's a 256 by 256 tile map. Okay, and I got to figure out if I need to subtract 1 or not. I'm not going to be able to comprehend that. But if I go, okay, well, let's think about what if the map was just 1 tile by 1 tile? Do I need to subtract 1 or not? And then by kind of think of it like that, it can kind of help you solve those fence post problems a little bit easier. Anyways, so tile map dot map height and -1. Okay, so we got these bounds, and then we need to kind of do that. And I'm just gonna, chances are I'm not gonna accidentally add anything, but just in case, as a good habit, we're gonna seal this object so we don't accidentally add any properties that don't belong. So the map width, map height, starting coordinates, and now we've kind of refactored all that viewport logic, right? This viewport bounds maps across the entire data set. Okay, so looking at that, do we have anything else we need to fix? And we definitely do. So down here, we have the x and y, which is okay, because it's still this x and y, right? So these x and y's and these x and y's are equivalent still. But the width here, right, that's going to be the var width for width equals the tile map dot map width, right? So add that in there, then take that underscore w, put the width in there. So now our formula is good, but we should probably factor out those 4s. So I'm going to say com for components equals the tile map dot map components, right? So 4 equals argb, and then we'll take those 4s and we'll put in that. So that kind of gets rid of our magic numbers. What else? So that looks pretty good. We're gonna now, if we do this though, I guess the problem with using a tile map as our input is that we're gonna have some duplicate code here, where if we really want to keep this code, we haven't really completely lexically factored the core of this code into here, into a more generic format that we can kind of reuse for this. You know what? But maybe I just should not worry about that, because redundancy is nice, right? Because we know this works, and then if this doesn't work, we can cross-check them against each other and be like, well, they're pretty much the same logic. So what did we screw up in our transcription? So try to be positive about the redundancies here. Okay, so looking at our top screen, make sure we didn't screw anything up here. Alright, so I made some type of syntax error, and I see map U8A, right? So that is on the inside. How do we want to do this? So going over here, this is not defined, and I know why. Let's take, just make a little comment. Actually, no, that should be the tile map. Set each component of tile map pixel. Okay, so I just needed to put the qualifier in front of that, and that should be good. So let's look at the top monitor, see what we got here, and close the debugger, refresh. Okay, so it's working again. Check the console. Don't have any bugs in the console, so I'd say we're good to keep on going here. I'm just gonna really quick look at where it's being called. Okay, so now we're in kind of a tricky position here, where we're filling this tile map with, a test pattern, and we did it with some refactored code, so we're pretty sure, we're confident that this is, filling it with the correct data, but we haven't written anything to see it yet. So what do we want to do here? Do we want to get some confirmation that this code works before we move further? And how would we do that if we wanted to, right? Because the less feedback we get before we finish writing code, the more possibilities for horrible things going wrong. But at the same time, if we're careful and we don't screw anything up and nothing goes wrong while we're coding, it'll be much faster to not, write code that's going to visually validate that this is working correctly, and we can just keep on building on top of it. I feel like I can trust this function for now. I think if we see any weird results, I'll probably be able to figure it out. And we can go back later and, reassess our situation if something goes wrong. All right, I'm going to stop this, record another one.